All right, so we have gone over rotations, reflections, and translations. So you've seen how those transformations move the shape. You've seen how the points on those shapes move with the different transformations. And then you've also learned the algebraic rules. So today we're kind of putting it all together and identifying which rotation, which transformation has happened. So we can do that different ways. First of all, we can identify it from a picture. So let's try it. So here we have a shape, and we know that this shape right here is the original, the pre-image, and we know that this shape right here is the image, and we know that because we see the prime symbols here on these points. It's not just A, it's A prime, it's B prime, it's B prime. So the shape has moved from here to here. This is the pre-image, and this is the image. And don't worry, we're going to start moving a little bit faster here in just a minute, but I want to make sure that we understand what we're doing with this first one. So if we look at where the points have moved, we don't want to just look where the shape has moved. We can see that A to A prime and B to B prime started at the top of the shape, and now they're on the bottom of that rectangle. Same with C and D. Now they started at the bottom of the rectangle, and when we did the transformation to them, they ended up at the top of that rectangle. So our verbal description is a flip, and the math word for flip is that it reflected. So we're going to write that it's a reflection, and it's over the x-axis. So the verbal description for this one is going to be reflection over the x-axis, and the algebraic representation is that rule. Remember, all the rules are going to start with x, comma, y, arrow, and then we have to decide what happened to the x's and to the y's. So since it flipped over the x-axis, the x stays the same, and the y becomes the opposite. So if we wanted to look at an example and make sure we were doing that right, point A right here, it is at -7, -3. And when we flip it, the A prime is at -7, +3. The x's stayed the same. The y started as a negative and it became a positive. So it was the opposite y. So taking a look at this next shape, it's moved as well. And we have to decide how it moved. So it starts here and it moves to here. So it turned 2 quadrants, which is 180 degrees. So the verbal description is the word for turn is rotation, 180 degrees. In this scenario, it's going to end up the same place whether we go counterclockwise or we go clockwise. So we really don't need to specify which way it's turning. The algebraic expression for a rotation that's 180 degrees, remember all rules start with x, comma, y, arrow, and then we have to say what happened to the x's and the y's. They both became the opposite. So h right here, to check our work, h started at 4, 2. H prime is at -4, -2. So we started positive x and we went to negative x. We started positive y and we went to negative y. So we know that we wrote that rule correctly there. This next one, we have to decide. It's moved 2 quadrants, so we know it's not a reflection or a flip. So our two choices are that it is either a rotation or a translation. Now, if you think about the orientation of the shape, the orientation is going to change on a rotation. But looking here, I, J, and K are all in the same places for the prime that they are for the not prime. So the pre-image and the image, the vertices didn't change. They're all in the same place. So if we think back to our rules, we know that that means that we're not turning that shape at all. We're sliding the shape. So this one, they were trying to trick you a little bit. So our verbal description, we know that it's a translation because a slide is a translation. We have to see how far it moved. So if I'm just tracking from J to J prime, J went 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. And then it went 1, 2, 3, 4, 5, 6, 7, 8 up. And then we're going to write the rule. Always start with X, comma, Y. And then we have to say what happened to the X and the Y. With translations, we start with the X and the Y. And over here, we say how far they moved. So the X moves to the left and the right. It's moving to the left, so I know that it's going to be minus. And it went 9 places. So it's going to be minus 9. The Y always moves up or down. Up means that it became positive. Down means that it became negative. So we know that it went up 8, so we're going to add 8. And there's our algebraic representation. We can also identify what the algebraic or what the transformation is from the algebraic representation. So anytime that we see a plus or a minus, the X plus or minus a number and the Y plus or minus a number, we automatically know that always tells us that shape is sliding. It's moving up and down and left and right. So we know this has to be a translation. The next one, we have a negative X and a positive Y. Here we have to look at our rules. We just go back, we have to have those rules memorized. We're going to determine, because when we have the negatives and the positives changing without any numbers before or after the X's and Y's, we know that they're one of two types. They're either a rotation or they're a reflection. And the only way to identify what they are is by looking back at our notes and looking back at the rule. In this case, the Y stays the same and the X becomes the opposite, but they're not changing positions at all. And since one is staying the same and one becomes the opposite, it's a reflection over the Y-axis. Here, the X stays the same and the Y becomes the opposite. Looking back at my notes, I'm going to look back at my notes and see if I can identify the type of transformation. And I see that it's a reflection over the X-axis. This one, if you'll notice this next one, the X and the Y changed places. That is your big hint, your big tell that a rotation has occurred. So I know it's a rotation, but I have to decide which rotation it is. Now again, I'm going to just look back at my rules to decide what the rotation is. In this case, I know that it's 270 degrees counterclockwise. So here we go again on this next one. We've got those minuses. Anytime we see a number, or the X plus or minus a number, we know without even having to think, hey, this one's easy. These are translations, the easiest ones to identify. And then finally, I have a negative X and a negative Y. Since both the X and the Y changed, that eliminates reflection. I'm not adding or subtracting a number, so I know it's not a translation. That leaves me with a rotation. And if I use the various tricks that I've used to learn the rotation rules, I know that it rotated 180 degrees. And it doesn't really matter. We could put clockwise or counterclockwise, but either way, it's correct because 180, it ends up in the same spot. All right, finally, we can identify which transformation occurred from points. So looking right here at point A, it started at -9, -3, and it's translated 4 left and 2 down. And we have to decide where A prime is going to be. So this is taking back some of my, what I've learned about the rules here. And applying it. So if it's going 4 to the left and 2 down, I have to think about what that looks like as a rule. Well, the rule always starts XY arrow, and then it says what happens to the X and to the Y. The X moves to the left 4. Since it's left and right, I know that that goes with the X. Left is going to be negative, and it goes 2 down. 2 down and up always go with the Y. Since it's going down, I know that it's negative. So I'm going to look at the original points and apply these rules. So for A prime, I'm going to go -4 and subtract 4. Remember, that's like saying I have a -9 and a -4, and I'm combining those two things together. -9 minus 4, which again you have a calculator, is -13. And then I have -3 minus 2. Again, I have a -3 and a -2. I combine those two. -3 minus 2 is -5. So that's going to be my coordinate for A prime. -13, -5. Point B. -5, 5 is reflected over the x-axis. Where is point B? So for this one, again, the first thing I have to think about is what is my rule for this? So it's being reflected, and it's being reflected over the x-axis. So XY arrow becomes, when it's reflected over the x-axis, the x stays the same and the y becomes the opposite. So since B is -5, 5, B prime, the x is going to stay the same. So it's going to stay -5, but the y needs to become the opposite. Since it's +5 to start with, it becomes -5. So that's how we could use the rules without even having to graph to apply them to the points and determine what B prime is going to be without even having, or what the prime is going to be without even having to graph the points.